Good afternoon. So nice to meet you, and thank you to Professor Milena for inviting me to take part in this workshop. Although I feel that my topic is a bit outside from the main topic of the workshop, and I will not present data analysis, data processing, data modeling. I will show you rather the pathway from where data comes to us, to analysis, to processing and modeling. And probably we will show you some difficulties connected and entered to this path. Our last project is connected to visual information processing in autism spectrum disorder. And we are trying to make some interdisciplinary and integrative research framework. Visual information processing is the main topic in our Department of Sensory Neurobiology. And vision is a very helpful area because we can control the input through controlling the parameters and measuring sensory processing, eye movements, neurodynamics, and behavioral responses. And of course, to try to integrate all the data in a common framework. As I mentioned, we can control the visual stimulus by controlling spatial frequency, duration of stimulus, position, contrast, of course, contrast. We can decide if the stimulus will move or not, and we can trace for not only for the final behavioral response of the participants, but also we can record their gaze position, which practically reshape the input information. We can record neurophysiological parameters like EEG or visually evoked potentials, and try to find the mechanisms through which the visual information is processed.
What do you measure? Gaze information?
From gaze positions during the stimulation.
Not the eye tracker?
This is eye tracking methodology. However, we can record the position of the left eye, right eye, both eyes, and some calculation of gaze, which is something between both eyes. They differ slightly. Of course, we can apply, depending on our aim, we can apply different analysis and compare all these parameters. As I told you, recent research directions in our department are connected to wider framework. We investigated visual processing in acquired hypothyroidism. Together with the team of Professor Komprinkova, we investigated stages in cognitive processing and conscious visual awareness. And now we've got a new project connected to visual perception in autism spectrum disorder. Besides the core diagnostic features of autism spectrum disorder, which are connected mostly to problems in social interaction and communication. It turned out that this condition shows a very atypical perception of sensory information, and especially visual information. Practically many studies documented differences between visual perception in autism and in groups with typical development. But I think that nowadays this is not very interesting. It is clear that the visual perception is different. The main question is why? Mechanism of this atypical visual perception is still unknown. And we will try to shed light on this question. We will try to link sensory processing, eye movements, neurodynamics measured by EEG and visually evoked potentials, behavioral responses, and conscious perception. Of course, at last we will integrate all the data and we will try to search for new parameters that show more clearly the mechanism through which this atypical visual perception occurs. We've got already similar project. So this field is not new for us. We answered some questions and opened many new questions. The previous project examined visual perception in 4 groups of participants with typical development, with ISD, attention deficit hyperactivity disorder, and dyslexia, in order to compare and try to recognize the specific features which are specific only for the autism spectrum disorder, for any of these neurodevelopmental conditions. We recorded behavioral performance, including accuracy, and the response time. We recorded eye movements and EEG and the functional near-infrared spectroscopy. And also made some psychological assessment in order to compare the perception in these neurodevelopmental groups. One of our tasks was to find a contour which integrated 12 Gabor patches. I'm not sure if you can see the contour. Okay. The distance is not proper. Okay, the distance is not proper. And moreover, here the contour is a bit curved. Actually, we used, I think, 6 noise levels, altering the position of individual Gabor patterns to make more difficult the task and to measure the effect of noise. The effect of noise on these 4 different groups. In fact, the group with autism spectrum disorder showed results which were less accurate and the longest response times. This is not very surprising, but I will show you later why this is not so important, this tiny result. Another experiment was connected to reading of words and pseudo words in a noisy environment. Again, noise. Moreover, there were two types of noise: pixel noise, here, which disrupted vocal visual features, and some kind of global shape noise, moving the letters, opened and destroying the global shape of the word. Interesting finding was that participants from the group with autism spectrum disorder showed again worse results with this task, but best results with the reading in pixel noise. I mean, when the noise was high, their responses were most accurate and faster than the other three groups. This was a very strange result, because actually we hypothesized that probably the group with autism will show worse results in each condition because of the noise, because the theory says that noise is difficult to be filtered by this population. However, they, as I told you, they read very fast and very correct in pixel noise. The conclusion: when the global shape is disrupted, the autism has problems. The people with autism cannot integrate the global shape and show, and their results are less accurate and much more slower. When the noise disrupts local visual features, their results are more accurate than the other groups and faster. Yes. You've got a question?
Yes. Did you measure there's a threshold where when you try to scramble the wall?
No, we didn't measure this. You mean in this experiment? We had 3 levels, and in all 3 levels, people with autism worse results. Again, I will show you later, a bit later. Here is comparison of accuracy, median proportion of correct responses between ASD group and typical development group in the contour integration experiment. You can see that at all noise levels, group with autism perform less accurate. Their accuracy is lower. And when they read words and pseudo words in pixel noise, would you notice that typical group with typical development, they've got less errors when the noise is low or without noise, and with increasing the noise level, people with autism read with less errors even than the group with typical development. Of course, group with dyslexia, they read always with much more errors. At the same time, it turned out that accuracy is not only a measure that we can integrate. Reaction time, time to response time, let's say, was very typically increase in group with autism, even in comparison to the other developmental conditions and of course to the typical development. Again, this is for the task with contour integration, but could you notice what happened in the reading task? Again, they've got, they read for faster than typical development. What happened? Noise sometimes make more difficult task, but sometimes for this group it's easier to filter it and to obtain the correct image of the word. So we think that yes.
But we know that this is a spectrum.
Sorry.
A spectrum. It's
Okay.
not, one flow.
I
The graph.
How what?
How we see this?
These are results which are averaged among 40, yes, 40 with something participants. The most variable data were in this group, and you will see soon that the same is the situation with their gaze. Most variable group with the best results and the worst results. Yes?
Yeah, follow-up question. Like, because also the spectrum, right, like you get very functional types, very like dysfunctional, intellectual.
High functioning, low functioning.
Yeah, whatever this means, right? And also like intellectual. And like, do you have a threshold by IQ or like do you use some kind of pre-selection there? Like how I've never done this. I'm very interested. Like,
you know, worldwide community that investigate, let's say, visual perception in autism spectrum disorder. They used to work with a very narrow sample of people who are high functioning, who have very high scores of full scale IQ, like 120 something. Even when I remember a talk on ECVP, I can't remember which year, but the lecturer told us that it was difficult to find from the typical population group with such high IQ scores. But the problem here is that this narrow sample is not representative for the spectrum at all. And we cannot speak about the spectrum and having results just for this narrow sample. I have to admit, at the beginning of the project, we tried to find a sample of very high functioning people with autism with very high IQ scores, and we didn't succeed. In Bulgaria, many, how to say, things are not well shaped. We didn't succeed because such people, they don't visit any centers, they function relatively well and don't ask for any help. We cannot find them. This was a very difficult decision, but we decided to try to make experiments with wider group, wider sample. Some of our participants had full-scale IQ like 58 or 62, I remember. It was very difficult to prepare experiments and to motivate them to participate, but we succeed. I will show you probably earlier, a bit earlier. Oh, here, no. probably I missed. Here. We prepared experiments in the form of computer games. And we told them that they will play computer games. Some of participants believe, some not. They were not usual computer games. Anyway, we investigated many efforts and time to make the environment comfortable and to ask the participants to cooperate. So we've got data from very, I wouldn't say low functioning people with autism. Just 2 weeks before our workshop, I visited them in one of the centers in Sofia with new experiments. Some of them, I remember a boy who was 10 or 11 years old, now he is teenager. Progress is obvious. He had a full scale IQ about 62. He performed absolutely perfect, especially in contour integration task. This was the very difficult task for this group, not for the other groups, no, but for autism spectrum disorder. So I wouldn't say that they were so low functioning, but with low IQ scores. Because quite often it turns out that many tests, including Wechsler intelligence scale, are not very suitable for studying such people. So about our experiments, we recorded eye movements, as I told you, left eye, right eye, both eyes, and gaze. We investigated fixation, stability, gaze allocation, and we tried through this information to find strategy, if there is different strategies to decide a certain task. What happened in contour integration, the group with autism spectrum disorder had most variable data, intra-individual variations. Also, the fixation instability was the highest in attention deficit hyperactivity disorder, but the variability was the highest in the group of the autism spectrum disorder. You can see how different position allocations in without any noise, just straight line or a curved line. In the other, our task, global motion direction, in this task, I'm sorry, in this task, points moved to the left or to the right. I mean, as a stream, points, the global motion of the stream was to the left or to the right. From the center of the screen, but depending on the noise level, individual path of each point was very variable in high noise conditions. And results again show that oculomotor characteristics of the group with autism spectrum disorder is more prominent, even most. They make more fixation with shorter fixation duration and large saccade amplitudes. Interesting, in the last experiment of reading words and pseudo words, again, the group with autism spectrum disorder had a very interesting and different oculomotor behavior, but fixation although unstable, was longer than the fixation from the other groups. You can see how density, like nests, are around their fixations around the words. Again, largest saccade amplitudes, much larger than the amplitudes in TD group. I like, it is interesting, I think, when through different experimental design, different tasks, you can reach the same or similar results. The amplitude of saccades in both experiments with global motion and refeeding was the highest, the largest in the group with autism spectrum disorder. In the counter-integration task, we cannot measure saccade duration or amplitude because the stimulus was very short, 200 milliseconds, and no time for saccades. Results were published, but many questions were not answered. And we need new project. Successfully was financed last year, and now we will try not to search simply for differences, but to explain the mechanism of these differences. Okay, and there are many theories, and each of them explains some part of the data, but not all the data. Probably because the theories are, how to say, they are focused on a particular phenomenon, and results from autism spectrum disorder are indeed variable and cannot be explained by simple mechanism. So we decided to trace each level in the visual system, starting from the eye optics, and we will perform very precise optical assessment, of course, psychological, psychophysical experiments, eye tracking, and we've got the new eye tracker. The part of the problem from the previous project was that our eye tracker was not very good, and actually we cannot capture all the gaze positions, especially in the group of autism with autism spectrum disorder, because the most data which were outside the screen were just for this group. This is very, very special and very characteristic for this group, that they tilt sometimes their head and don't look straight. Why? Theories explain this by social communication, by attempt to avoid direct gaze, access to eyes, but we've got another explanation, not without evidences so far, just yes, a bit later, I will. I will preparing you for this. Here our hypothesis. In fact, we think that early, I mean before a primary visual cortex, in the magnocellular and parvocellular visual pathways from the retina to the cortex, there is some imbalance, something different with the timing of spatial frequency information processing, which will lead to this preferential focusing for people with ASD on details, not because they've got very high visual acuity. This was wrong methodologically, wrong experiment, and recent findings, recent articles and studies don't confirm this finding. Why? Another point in our hypothesis, besides the spatial frequency processing, is that gaze and saccadic mechanisms may affect visual stability and information sampling in different way, comparing to typically developing people. And in practically, behavioral responses may reflect both sensory processing, task strategy, and may not be related only to social stimuli. Our project didn't involve any social stimuli, and we obtained data which are not connected, which illustrate atypical visual perception in ASD and not connected absolutely to social communication and interaction. So there is something before this. Important part of our project is inclusive research. Inclusive research, which I'm not sure if know about this new trend in the science, to include the participants not only as a source of data, but even before the experiment, when planning experiments, environment around the experiment, tasks, and even research questions. And after the experiment, when you analyze the data and make conclusions. I think that this inclusive research will be very helpful because I have personal experience with this. 11 years old girl with autism couldn't recognize, even without noise, couldn't recognize the contour. No, I don't see contour. From the moment when she decided, we had many materials preparatory to train the participants to recognize the stimulus. And even we prepared a contour from coffee beans. When, yes, in order to touch it, to be introduced to the task. And at certain moment, she decided that this is not a contour or wine or puff. This is the tale of a Catwoman, some hero from movie, or I'm not sure. The tale of a Catwoman. From this point, she recognized all the contours, even with more noisy. So what's the conclusion? If researchers decide not to pay attention to such details, she or he could judge that the participant cannot see, just cannot see, cannot integrate the contour. Oh, what happened? This is wrong decision. This is wrong conclusion. So inclusive research will help us to avoid such wrong conclusions.
Fits to my inspection. Something is not relevant to me.
Sorry?
Your story
Yes.
fits to my introspection.
Aha.
If I'm moving around in our apartment and something is not relevant to me, I don't see it. I may not see it for weeks.
4 weeks. But probably every one of us can remember such thing. Yes, yes, every one of us can. Autism spectrum disorder spectrum. Now we now we could find how deep are we in the spectrum. I'm joking, of course. um, as I told you, we will work and try to take precise measurements of optical function, including near and far visual acuity, stereo vision, color vision. And as I told you 2 weeks ago, we performed the first experiment. Optometrists from the Faculty of Physics who work together with us on this task, they also notice that very often people with autism tilt their head and look a bit outside the point of interest. Although cover tests showed no anything different, or refractometry didn't show any astigmatism, no. But this behavioral manner, my personal idea is that this behavioral manner helps them to filter high spatial frequency content of the visual scene, because they've got okay, a bit later. As I told you, we will modulate visual stimuli and involve different stimuli with different contrast, spatial frequency, and noise level. We will measure response time, accuracy, detection threshold. And back to spatial frequency analysis and our first working hypothesis. The previous results in the literature on this topic makes me to think that people with autism tilt their head because they want to filter high spatial frequency content in the environmental scene. Like they very successfully made this with the pixel noise. Pixel noise has higher spatial frequency than the words, and their performance was better than the other groups. It is very important to process and the high low spatial frequencies to be the first who reach the primary visual cortex through magnocellular pathway, because we need these frequencies to create global object representation. High spatial frequencies gives local visual features and details, but they cannot help us to appreciate global visual object shape. I think that we suppose that people with autism, for some unknown mechanism, they delay low spatial frequencies, and in such way they cannot take advantage of global precedence. That is because that is why they are focused on high spatial frequencies and local visual details, and that is why they tilt their head and try to filter information that is noisy and that makes difficult to appreciate low spatial frequency. This is our idea. Are you ready to see something? Here. What was? Sorry? Trees? Of course, the distance is not proper, it's different. At first instance, you should see the elephant and a bit. Couldn't you integrate? You should move further. You should move further. Oh, here is the elephant here and legs. This is not the test. Yes, elephant, because this is a global form. But it depends on the distance, on the size of the elephant, and so on. Yes. Okay. Are you ready for the next? Be more careful, please.
No,
No, but
with a number.
with the numbers, more answers. Letters. Which letters? Which letters were incorporated in N and which in O?
Yeah.
Okay, another time.
Zero.
Okay. This is global precedence phenomenon. You can read no, but you cannot recognize O or N's. You can see the forest before tree. And could you imagine if people with autism lack this? Their perception would be completely different from our, and without any social interaction and so on. You know that visual system is probably processing about around 80% of the information in our mind. So it can make many illusions, and practically what can we see is not the real world. We can see what are our limitations of our visual system. Yes.
Are these pictures, such as the one with the elephant, used to identify autism?
No. The global precedence, Navan figures. You can find about Navan figures and global precedence. No. No.
Yeah.
The time that someone could say trees, elephant, etc., it's 2 years. This is already surfaced.
I think that the present situation is that there is no any objective method to identify autism. There are long interviews with parents, with the person, and so on. But I think that eye tracking is very, very helpful method, and soon it will be included, I think, as a help. The phenomenon of global precedence is in partly reflected in this picture. You can see that the stimuli with low spatial frequency are processed and transferred to the cortex very much more faster than the spatial frequency information with high spatial frequencies. But this is very important, as I told you, for global object information. Here are just numbers that with high spatial frequency you have delayed latency and reaction time compared to low spatial frequencies. Let's go back to our present project. The other hypothesis about saccadic suppression and visual stability, as I mentioned, we suppose that in the group of people with autism spectrum disorder, they appreciate in different way visual world during saccade movement, and we will check this. And after all these measurements, we will try to integrate all them, in a semantic graph database in order to support integrated analysis and modeling. And our aim is not only to collect different results from different tasks, but to connect separate measures and to find the mechanism through which different levels in visual system interact and result in atypical visual perception. In autism, of course, this could help to reveal mechanisms of visual perception beyond autism itself, but it could help to prepare some individualized assessment and support strategies for people with autism. Thank you.
This was very interesting. I know nothing about this, so maybe not a good question, but I was interested in, so this was all vision. Like, do you also do experiments, or do people do experiments with like vision and audition at the same time? Like, to see how they interact? Is there
Yes, there are such experiments, even when the two senses in conflict and vision wins.
a vision?
Yes, I know about experiments when visual and vestibulary systems are confronted. Let's say people post with the legs upright and head down, but they are projected with visuals and they claim that they stay right. Visual system usually wins.